So we're now going to talk about the implementation of the structured task scope ShutdownOnSuccess nested subclass. And this class, of course, is the one that's going to capture the first result that returns successfully, shut down all the other threads in the scope, and then return that result. So once again, you can get the code here from this link at the bottom of the slide. It's just nested as part of the structured task scope file. So here we are back in my IntelliJ project, and we're taking a look at ShutdownOnSuccess. And you can see that ShutdownOnSuccess is nested inside of structured task scope. And you can see that it inherits from structured task scope. So it's this kind of curious thing where it's both nested and also inherits from or extends the class that it's nested inside of. Much like structured task scope, this also uses a var handle. It uses it for a slightly different purpose, however. What it uses the var handle for in this case is to be able to perform portable atomic operations on the future field. There's a future field down here. And this field keeps track of the result of doing the ShutdownOnSuccess scope. In particular, it'll either keep track of what succeeded or failed. And as before, you can see that we use Java reflection in order to go look up in the ShutdownOnSuccess class here. And we're going to look for the field named future, and we're going to treat it as a future, which is exactly what it is. So we get this var handle, and you'll see how we use it later whenever we want to do atomic operations that don't require full-blown synchronization. So it's used again for these super fast spin lock, compare and set operations, or CAS operations. There's a couple of constructors here. They pretty much mimic what's in structured task scope. For example, you can see that ShutdownOnSuccess takes a name and a thread factory, and it just passes those up to its parent class using good old object-oriented features like inheritance. There's also an anonymous version of ShutdownOnSuccess, which is the one we typically use in our examples, where it's unnamed and it's going to allocate virtual threads. We'll talk about virtual threads here, but be aware that you could also implement things using platform threads if you called this constructor and passed in a thread factory that made a platform thread. Most of the behavior of ShutdownOnSuccess is inherited from the methods we already looked at in structured task scope. So fork, for example, the future impulse stuff, a bunch of other things, join, and so on and so forth. And so what you can see here is the handle on complete hook method, which is the part that's overridden. So handle on complete is overridden from the structured task scope. And what it's going to do is it's going to shut down the given task scope when it's invoked for the first time, the future for a task that completed successfully with a result. And so let's go ahead and take a look at this. So here's what it does. When this method is called, it's past the future that just completed. So remember, you fork something, you get a result that is passed back from the callable, and it comes back as a future to type T of whatever thing you were doing. And now we're going to take that future and we're going to go ahead and take a look at the future's state. And the concept of future state was something that was added fairly recently to Java. So if you take a look at the latest version of Java, the one that relates to this, either Java 19 with the incubator mode or Java 20, you'll see that they've added some new things to future. And in particular, they have this concept of a future state. And if we search down here for state, you'll see what we've got. Here's the state method. By default, the state method goes ahead and checks to see if we're not done, in which case we're running. That's our state when it's called. If we've been canceled, we're in the canceled state. And otherwise, if we're not running and we're not canceled, we're done. And we are either going to be successfully done or we're going to be failing done. And to see which it is, we call the get method. And that, if it doesn't throw an exception, we know we succeeded successfully. So we return success as the state. Otherwise, if it returns the execution exception, that indicates that we're in the failed state. So that's basically the way we find out what state we're in. And so the ShutdownOnSuccess implementation of handle complete first takes a look at the state. Now, if the state says we're running, something really weird is going on. And we really shouldn't be in this mode at all. So that's kind of just like a sanity check. more likely it will have been completed, so it will not be running. So then what we're going to do is we're going to do some little fancy footwork using the var handle technique we looked at before. And we're going to go ahead and try to set the future field that's in the class ShutdownOnSuccess that keeps track of what the first thing that succeeded or failed. And what we're going to do is we're going to go ahead and atomically take the future parameter that was passed to the handle complete method and try to atomically write it to that field. And if we are successful in doing that, and if the state of the future that just completed is success, that means we're finished. It means we've found the first successful task that completed, and that means we are going to shut down all the other threads running in this scope. So remember, shutdown, which we inherit from structured task scope, we'll go ahead and close down all the other threads in the flock. And then we break out of this loop and we're finished. So basically what this is going to do is if we succeeded, we shut down and break out. Otherwise, if we didn't succeed, if we failed for some reason, we're going to break anyway, and that's going to be reflected in a different way. But we've updated that future to indicate what's going on one way or the other. So we shut down on success. If something fails, we don't shut down. We keep going. But if something succeeds, then we shut everything down. And that's an important distinction, and we'll talk a bit more about that when we look at some examples. You can see that the join method for ShutdownOnSuccess just calls up to the parent's join method. Join until does the same thing. But here's the result method. Now, result method is something that's been added to ShutdownOnSuccess. You don't have a result method for structured task scope. And what result does is it takes the future that was set up here when we did this compare and set operation. So this is the one that finished successfully. And what we're going to do, it might have finished successfully, or there may have been nothing that finished successfully. So if it turns out that nothing finished successfully, then this future will be null. And so we throw an exception that says nobody completed. That's called an illegal state. Otherwise, we take a look at the state of the thing that completed, and if it's success, then we just return the result. We're done. If it failed, we throw a new execution exception indicating what the actual exception was. And if it was canceled for some reason, then we throw the cancellation exception. So these are the different states that a future could be in, and that's going to dictate what the result does. It either returns the result of the future if all went well, or it throws different kinds of exceptions depending on what has happened. So there's also another result method where you can give it an exception to throw if things weren't copacetic. So that's basically how ShutdownOnSuccess works. And we're going to take a closer look at this when we apply it in an example here in just a moment. But I want to make sure that we cover the topic before we then show an example. I want to make sure we looked at the source code before we take a look and see how it works.